In this video, we're going to take a look now at a couple of examples of special matrices. Now, when we talk about special matrices here, we're concerned with two things in particular. The first one being a square matrix, and then the second point being the identity matrices. So if we start with a square matrix first, this is just a matrix where the number of rows is equal to the number of columns. So for example, a 2 by 2 matrix like this here would be a square matrix. Again, a 3 by 3 matrix would also be a square matrix because the number of rows, 2, is equal to the number of columns, again, 2 here. Now, it doesn't matter what the elements are of the square matrix. So, for example, I might have 0, 4, 2, 7, for example. Doesn't matter what those elements are. Could be numbers, or we could have an algebra. So, for example, I could have A, B, C, D. That would also be an example of a square matrix because the number of rows, 2, is equal to the number of columns. Again, 2 columns there. And if I give an example of a 3 by 3 square matrix, let's say, again, doesn't matter in particular, 3, 4, 2, 5, 7, 8, 10, 0, 4 there. I'm literally just picking numbers at random. Doesn't matter as long as the number of rows is equal to the number of columns, then we have a square matrix. However, though, for an identity matrix, the elements do matter. Okay, so we can't just pick these at random. And the identity matrix is important because in terms of matrices, this acts as the number 1, okay, when we're talking about multiplication, for example. So for an identity matrix, so if we take a look at the 2 by 2 identity matrix first, and again, just notice this notation here. So we're using this capital letter and in bold again to represent our matrix. And this subscript of 2 here, that just tells us the dimensions of the identity matrix. So I2, that's the 2 by 2 identity matrix. So if we take a look at I2 here, it's the 2 by 2 identity matrix. Well, for a 2 by 2 identity matrix, what we're particularly concerned about here is this main diagonal. Across this main diagonal here, all the elements are 1. So we're going to have 1 in the top left and 1 in the bottom right. And for all the other elements in our matrix, that will be, or those elements will be 0. So top right here will be 0, bottom left will also be 0. So that gives us the 2 by 2 identity matrix. So if we take a look at the 3 by 3 identity matrix here, so that's I3, again, we're concerned with that main diagonal. So going across this diagonal here, those elements will be 1, everything else is a 0. So we're going to have 1, 1, 1, and then everything else will be a 0. Remember, this is a 3 by 3 matrix, so we'll have another 2 zeros across the top row here. Then we're going to have 0, 1, 0, and then finally 0, 0, 1 there. And that gives us our 3 by 3 identity matrix. So one final example for you to have a go at here, we're looking now at the 4 by 4 identity matrix. So like always, pause the video now, have a quick go, and then we'll take a look together at what you should have got. So hopefully you got an okay with this. Let's take a look now at what you should have got. So this is a 4 by 4 identity matrix, so we're going to have 4 rows, 4 columns. Okay, so for I4, we know we're going to have 4 rows and 4 columns. Now, we're getting into quite large dimensions here, or larger than we started with. So what I'm going to do first is just put my top left element in of 1, and then go across. So 1, 1, 1, and hopefully this will give me enough space. So we're going to have 0, 0, 0 for my top row, and it will be 0, 1, 0, 0, 0, 0, 1, 0, and then finally along the bottom row, 0, 0, 0, 1. And there we have it. So that's the 4 by 4 identity matrix there, and that's what we should have got. So that brings us to the end of this video. In the next video, we're going to take a look now at addition and subtraction of matrices. So thanks for watching.